All right, we're going to start chapter 7. This entire chapter is dedicated to exponents and radicals, which you guys have seen before. We're just going to go into a little bit more detail with the properties and try to simplify some expressions. All right, so you guys know what an exponent is. You guys should know what it does. All right, so for example, 3 squared, or 3 to the second power. 3 is going to be your base, right, and then 2 is going to be your exponent. Right, so 3 is going to be your factor, and then you multiply it by itself 2 times, right? So 3 squared is just 3 times 3, which is 9. All right, and then if you did it even further, if I did 3 to the 4th, right, that's the same as 3 times 3 times 3 times 3, and that gets you 81, right? But let's say I had a 3 to the 0 power, right? Or a 3 to the negative 1. All right, what does that get you? All right, well, let's look at this table, right? For example, in this table, we're looking at values of, bases of 5 with some exponents, right? So we can see starting at the first one, 5 to the 5th power is going to get us 3,125. 5 to the 4th power is going to get us 625. So each time you keep going, just like if you keep going up, you can multiply by 5. Right, so 5 to the 3rd, you just multiply another 5, right? 5 to the 4th, you multiply another 5. Right, you can do the same thing in the backwards direction. Right, so you can go backwards by dividing by 5, right? Divide, 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 divide. And if you keep dividing by 5, what happens when we get to 5 to the 0? Right, so if we get to 5 to the 0, right, that's just another divided by 5, right? And then 5, I take this number that I had previously divided by 5. Anything divided by itself should get you 1. Right, so 5 divided by 5 gets you 1. And then if you keep going, and you divide by 5 again, right, 5 to the negative 1 is going to get you 1 divided by 5, right? There's no whole number that's going to get you, right? But we can leave it as a fraction, right? As a fraction, this is just going to get us 1 over 5, right? And then you can keep going again, right? So what happens if you have bigger negative exponents? Right, we can divide by 5 again, and if I take what I had previously, this 1/5, and I divide it by 5 again, right, well, we can keep change flip, right? So keep in mind, this division is going to become a multiplication, and 5 is the same as 5 over 1, so we can just flip it, and then we get 1 over 5 times 1 over 5, and then multiplying straight across, we get that this is 1 over 5 times 5 is 25. 1 over 25. All right, so that's what happens when we keep decreasing our exponents, right? So you can see that we end up with 1 when it's raised to the 0, and then as we go negative, we get fractions, right? So that's going to be the case for any negative and for any 0 exponent. All right, and these are properties, right, that you guys are going to need to know. You guys are going to get very familiar with them. Our first property is a 0 exponent. So any non-zero number raised to the 0 power is going to get you 1, right? As you could see from the previous slide, when we kept dividing by 5, right, we got 1, right? So any number that you have, right, and we see a whole bunch of examples here, right? Any number raised to the 0 power is going to get you 1, right? It doesn't matter what it is as long as it's not 0, all right? Now with a negative exponent, similar ideas, so I have a non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite exponent, right? That's a lot of words, right? But essentially what we mean is that if I see something like this, a 3 to the negative 2, right, a negative exponent is just going to flip it, right, and make it into a fraction, right? So again, treat this as 3, let me erase this, right? Treat this as 3 over 1, right? And all we're going to do is we're just going to flip the places and turn this exponent positive, right? And then so we get 1 over 3 to the second power, and then 3 to the second power, I know that's just 3 times 3, which is 9, right? And I could do the same thing with 2 to the negative 4, right? If I put it over 1, right, all that's going to do is it's going to bring it to the bottom and make the exponent positive, right? So then I get 1 on top over 2 to the 4th power, and then 2 times 2 times 2 times 2 is going to get you 16. Right, so that's, in general, is going to work out with a rule that's going to look something like that. right? But it'll make more sense as we do some more examples, right? But that's the general idea. Anytime you see a 0 exponent, it's going to equal 1. Anytime you see a negative exponent, it's just going to flip its position, and it's going to make the exponent positive. All right, so these are just some things to remember, right? So this big number that we have here, this is called our base. And then this little number is what we call the exponent, right? Please don't forget that terminology, right? If I'm talking about a base, I'm talking about the big number. And then if I'm talking about the exponent, I'm talking about the little number on top. And then if I have something like 2 to the negative 4, you're just going to read it as 2 to the negative 4th power. Or you can say 2 to the power of negative 4, right? So either one is fine, right? But just so that you guys get familiar with, I don't know, speaking it and hearing it, right? I know some of you say it different ways, right? But this is how you properly say it. All right, so let's try simplifying some examples. This first one, I have 4 to the negative 3, right? Now, we had said that a negative exponent is just going to bring it to the bottom, right? So if it's on top, right, treat this 4 as a 4 over 1, right? And that's just going to bring this 4 to the bottom and turn that 3 positive, right? So this is going to become 1 over 4 to the positive 3, right? And then you can do 4 to the positive 3 on the side if you need to, right? That's just 4 times 4 times 4, right? And then 4 times 4 is going to get you 16. And then if you have to do 16 times 4, that's going to get you 64, right? So this 4 to the negative 3 is going to get you 1 over 64. All right. And then part B, 7 to the 0 power. Well, I know that anything to the 0 power is going to get you 1. It doesn't matter what the base is, right? So 7 is my base here. 0 is my exponent. This is just going to equal 1, right? Nothing more to do there. All right, now for this last one, again, I have a negative in the exponent, right? But be careful here because we know that we see a negative in front of the 5, but not always when you see a negative are you going to flip it, right? It's only if you see a negative in the exponent, right? So I see a negative up here with the 4. That's our clue that that's going to flip it to the bottom, right? And I'm going to put it over 1, so this is going to become 1 over and then negative 5 to the 4th power, right? And then on the side, you can do, if you need to, negative 5 times negative 5, right, times negative 5. All right, and then negative 5 times negative 5 is going to get you 25. And then times negative 5 again, that's going to get you negative 125. And then times another negative 5, right? We have a negative times a negative. That's going to get you a positive 625. Right, so it's going to equal 1 over 625. Right, so it's a new skill for a lot of us. But hopefully we get the idea. All the negative in the exponent does is it brings it to the bottom. And then on the bottom, right, if I had given you this, negative 5 to the 4th, way back in the beginning of the year, I would expect you guys to know how to evaluate that. All right, and then now we can evaluate some expressions, right? So, for example, if I have x to the negative 2, all I have to do is I'm going to plug in this value wherever I see the x. Right, now there's a couple ways you could do it. You could plug it in right away, and I could say 4 to the negative 2, and then simplify that. Or you could change this negative exponent from the beginning, right? If I have x to the negative 2, right, I know that that's the same as x over 1, and then I can bring this x to the bottom. And then it becomes 1 over x to the 2nd power, and then from here just plug in 4. Or it doesn't make a difference, really, if I had just done it plugging in the 4 from the beginning, right? Because I could bring this 4 to the bottom and then change this exponent positive. All right, but either way, you should get 1 over 4 to the 2nd power. And then 4 to the 2nd power is 4 times 4, which is 16. Right, so we get this answer right here is going to get us 1 over 16. All right, now you can do the same thing with p to the negative 3, right? So again, you could choose to plug it in from the beginning, right? So I'm going to take this 4 and plug it in right there, and then we get 4 to the negative 3. But again, if I see a 4 to the negative 3, that's just going to become a 1 over 4 to the positive 3, right? That's going to, I can write that over 1, and I can bring it to the bottom. And then this negative 3 becomes a positive 3. And then 4 to the positive 3, we had done that in a previous example, right? 4 times 4 times 4 is going to get you 64. All right, so I get 1 over 64. All right, now the examples seem to get a little bit more complicated, right? But again, all I'm doing is I'm substituting the values that I see, right? So all I'm going to do here is I see that a equals 5. I'm going to plug in that 5 wherever I see the a. All right, and I see a b equals negative 3. I'm going to plug in that negative 3 wherever I see a b. All right, so I'm going to write out exactly what I see, and it's going to be a negative 2. And then instead of an a, I know that a is 5, so it's going to be 5 to the 0 power. And then b is going to be negative 3, so I have a negative 3 to the negative 4th power. All right, so I just want to go one by one, right? Keep in mind, these are all being multiplied by each other. All right, so I have a negative 2 times 5 to the 0 power. All right, order of operations says to do your exponents first. Right, so if I do my exponent first, 5 to the 0 power, I know that anything to the 0 power is 1. Right, so I'm going to replace this 5 to the 0 with a 1 and bring down that negative 2. Right, and then next, if I have a negative 3 to the negative 4th power, I know that that negative exponent is going to bring whatever I have on top to the bottom and then turn that exponent positive. So this is going to become times 1 over negative 3 to the 4th power. Right, positive. Right, and then I can go ahead and just multiply straight across, right? Negative 2 and 1 are both integers, so they're going to combine with whatever's on top. Right, so then I have a negative 2 times 1 times 1. That's going to get me a negative 2 on top. And then on the bottom, I have a negative 3 to the 4th power. Remember that that's just negative 3 times negative 3 times negative 3 times negative 3, right? 4 times. And then negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is a negative 27. And then a negative 27 times a negative 3 is going to get you a positive 81. Right, so then on the top, I still have that negative 2. On the bottom, I have a positive 81. Right, and then this is your final simplified answer. Right, so kind of tedious to evaluate after plugging it in, but again, just take it one step at a time and it should be fine. All right, so let's do the same thing with the next one. Right, I have a equals negative 2, so I'm going to go ahead and plug that in wherever I see the a. And then I have a b equals 6, so I'm going to plug that in wherever I see a b. All right, and then I have an 8. A, I know that that's negative 2. All right, to the power of negative 2. And then b, I know that that's 6, right, to the power of 0. Right, so again, doing order of operations, you do your exponents first. So 8 stays the same. All right, and then negative 2 to the negative 2nd power. Again, this negative exponent is going to bring whatever you have to the bottom. So it's going to become 1 over negative 2 to the 2nd power. All right, and then I have a 6 to the 0 power. Anything to the 0 power is going to get you 1. All right, so then I'm going to go ahead and simplify this a little bit, right? So this is going to become 8 times, and then 1 over negative 2 to the 2nd power. That's just negative 2 times negative 2. And negative 2 times negative 2 is 4. All right, and then times 1. All right, and then once again, 8 and 1 are both integers, so they're going to multiply with whatever's on top. So 8 times 1 is going to get you 8, and on the bottom I have a 4. And then 8 divided by 4 is going to get you 2, right? So this whole expression right here that we had in the beginning just works out to be 2, right? So make sure you simplify fully, right? You clean up your answer as much as you can. All right, so here's another big idea involving negative and zero exponents. We talk about simplifying exponential expressions a lot, and you'll hear me say that a lot in this chapter. Now, To fully simplify an expression, you want to make sure that there are no zero exponents or no negative exponents. Anytime you see a negative exponent, that is not simplified, right? So that's what this sentence says here, right? Any negative or zero exponent that you see in your expression is not simplified. You need to evaluate those, all right? Now, we've also only ever worked with numbers that we've seen, for example, like a whole number, right? 3, right, to the negative 2, right? Something like that. And then what we did is we brought it to the bottom, 1 over 3 to the second power, and that got us 1 over 9, right? But what if I had a 1 over 3 to the negative 2, right? If I had a negative exponent already on the bottom, right, that's not going to make it go to the bottom again, right? So I'm not going to put it over 1 and then go through all that process. No, I'm just going to bring it, I already see it in a fraction, so what I'm going to do is I'm just going to bring it to the top, right? So all the negative exponent does to a fraction is switch its position, right? If it starts on the top, it's going to go to the bottom, and if it starts on the bottom, it's going to go to the top. So this is going to become 3 to the positive second power, right, over 1, which is just 9 over 1, right? But 9 over 1 is just 9, right? So in general, if I have x to the negative n, then that n, to make it positive, I'm just going to bring it to the bottom. Similarly, if I had 1 over x to the negative 8, right, to make this 8 positive, I'm just going to bring this x to the negative 8 on top and then flip the sign. This is going to become x to the positive 8. All right? So that's a big idea. Anytime that you see a negative exponent, you're going to want to flip its position and change the sign, right? You cannot leave your answer with a negative exponent. All right, so let's simplify some examples, right? So for A, I have a 7w to the negative 4, right? One thing to know is this negative 4 going to the w, or is it going to 7w, the whole thing, right? Think about that. This one is actually going to be just over the w, right? So I know a lot of you see the 7 in front of it. It's actually just going to the w because we don't see it grouped in parentheses like this. Unless you see parentheses, then it's only going to be over whatever variable you see right next to it, right? So let me go ahead and erase this. So that means this w is the only thing that I'm going to flip its position, right? So I'm going to write this as 7 over 1 w to the negative 4th, and then to make this negative a positive, I'm just going to bring this entire expression to the bottom. And then we have a 7 on top over 1 times w to the positive 4, right? But 1 times anything is itself, so this is just going to become 7 over w to the positive 4, all right? And this is fully simplified, right? I don't see any zero exponents, and I don't see any negative exponents, right? So that's all we have to do here. All right, now let's look at B. I have a negative 5 over k to the negative 2. Now, I need you guys to be careful with these kinds of problems because this is a common mistake that I see even in Algebra 2. Right, so I've done this lesson in the very beginning of the school year of Algebra 2, and a lot of people, what they do is when they see this negative, they're tempted to immediately move it to the bottom, right, or immediately flip its position, right? This negative in front of the 5 is not in an exponent, right? It is just saying that your value itself is negative. Our exponent is not negative, right? So this negative 5 is going to stay on top. There's nothing to do there, right? I don't see any sort of exponent on top of it, so leave it alone completely, right? Don't even touch it. What you should have to worry about is this k to the negative 2, right? Because this negative 2 is what we see in the exponent, right? And I don't want a negative exponent, so to make it a positive, I'm just going to bring it to the top and change the sign, right? So bring it right on top with that negative 5, and this is going to become negative 5 times k to the positive 2 over 1, right? But anything over 1 is itself, right? So I'm just going to fully simplify it. It's going to be negative 5 k to the positive 2, all right? And now let's look at C, right? So I have a lot of things going on in C, right? Take it one step at a time, right? So I'm just going to focus everything on the top and then do everything on the bottom, right? So looking at the top, I have an a to the 0, right? What did we say anything to the 0 power is, right? That's just going to get you 1, right? So 1. And then b to the negative 2, I also have that on top, but again, the negative exponent is just going to flip its position, right? So I'm just going to bring it to the bottom, right? Do the same thing with c to the negative 3 on the bottom, right? So if I have a negative in the bottom, that's just going to move it to the top. And then d to the 6, that 6 is already positive and it's not 0, right? So you don't have to do anything to d to the 6, right? This one's fine. All right, so now I'm just going to write my answer with everything that we had just mentioned, right? A to the 0 I said is 1, right? And then times c to the negative 3, I moved that to the top. It's going to become c to the positive 3 over, and then I said b to the negative 2, I moved to the bottom, so it's going to become b to the positive 2. And then d to the 6 stayed the same. All right, and then clean it up a little bit. There's not really much you have to do here, right, other than get rid of that 1, right? 1 times anything is itself, so all I can write is c to the 3rd over b to the 2nd, d to the 6th. All right, and that would be your final answer. All right, last slide for this lesson. Let's just keep simplifying, right? So again, go 1 by 1, right? I see a 2, right? That 2 is not being raised to the 0 power, but what is this r, right? So this 2 is fine, but r, anything to the 0 power is going to get you 1. All right, so I'm going to have a 2 times 1, and then times m to the negative 3, right? This negative 3 is going to move it to the bottom, right? So it's going to become 1 over m to the positive 3. And then from here, you can go straight across, right? So 2 times 1, all on top is going to be just 2. And then I'm going to have an m to the 3rd on the bottom. All right. I could do the same thing with b, right? Go 1 at a time. I have an r to the negative 3, right? On top, this negative is in the exponent. That's going to move it to the bottom with the 7, right? And there's nothing to do to 7 because it doesn't have any sort of exponent on it, so there's nothing to simplify. So on the top, the only thing that you're left with is a 1. On the bottom, I have a 7 to the times r to the positive 3. All right, and that's all you have to do with that one. We have no 0 exponents, no negatives, so we're good. All right, let's do the same thing with this one. I have a g to the positive 4 over an h to the negative 6. All right, this negative 6 is an issue, right? I don't want any negative exponents, so I'm going to bring it to the top and make it positive, right? So this is going to become g to the positive 4 times h to the positive 6. And that's all you have to do. There's no 0 exponents, no negative exponents, so we're good. All right, and that's the lesson. That's all the kinds of problems that I would ask you in this lesson, so make sure you get comfortable with these.